10.
let's go for main engine start.
6, 5, 4, 3, 2, 1. And booster ignition and liftoff of Space Shuttle Discovery, taking the space station to full power for full science.
12 miles. No contact approaching 5 miles. Contact 70 miles, final break. 3230. Mile and a half.
Still single contact. 6,000 feet, speed 350, 340. Heads up, it's 30 west, Cali House.
Team.
1 Alpha has 2 contacts, 166 at 11, Angels 5.
On today's episode, Advances in Space Propulsion, we dive deep into the current and future states of space propulsion, and we look at what those systems could look like for advanced civilizations. Join us for an O.S.I.R.I.S project special with NASA Shuttle astronaut Tony Antonelli. Hey, welcome back, folks. This is episode 2 of the O.S.I.R.I.S project. Waiting back in the green room, we have 2 special guests. We have, as I said in the intro there, Tony Antonelli, the NASA shuttle pilot of STS-119 and STS-132 with us, and we're going to be discussing the history and advances in space propulsion. And Tony can only be with us for about an hour today, so I won't take up too much time with this introduction. However, this is a bit of a continuation from episode 1, where Dr. Szydagis, Gary Voorhees, and myself discussed the death of Moore's Law, and if that could be the impetus for the government's new push on disclosure. During that conversation, Dr. Szydagis, who is also with us today, mentioned that the demise of Moore's Law wouldn't necessarily affect propulsion systems, and that radical new feats of engineering could bring about significant advances in how we get through the stars. The modern space age took flight with the launch of Sputnik 1 back in 1957. So why are we 64 years later still using basically the same propulsion technology? Well, let's find out why and what the future holds as we bring in Professor of Physics Matthew Szydagis, as well as our special guest tonight, NASA astronaut Commander Tony Antonelli. Gentlemen, welcome. Thank you for being here tonight. It is an honor and a pleasure. Commander, thank you. Professor, thank you. Gentlemen, welcome to the show.
Thanks for having me.
So, absolutely. It's an absolute honor. You are, I believe, honestly, the first astronaut that I've actually had the pleasure of speaking with. Now, at UAPX, we do have on staff Christopher Altman, who is a NASA-trained astronaut, but to my knowledge, I don't believe he's ever actually gone up. So you're making history for us here. Tony, you said you had a chance and an opportunity briefly to take a look at episode 1, where we were talking about the death of Moore's Law and how this could possibly be an impetus for roughly 180-degree change in direction from the way that the government is now talking more and more about UFOs and UAPs. Do you feel that is a solid hypothesis?
No, and like I don't. I wouldn't describe it as a death of Moore's Law any more than the death of any other inanimate object like my desk or something. I was reminded of a quib I heard decades ago, maybe when I was a freshman, right? And so I'll take some liberties and change the story a little bit. But an engineer and for Matthew's sake, I'll say theoretical physicist are showing up in the room, and they see somebody across the room that's very attractive, and of course they're as the stereotype would have it, they're both shy. So the physicist decides to come up with a plan for how to introduce himself to this person. And so he says, okay, each day I'm going to close the distance, and I'm going to be halfway closer every day. And so a few days of watching this go by, and theoretically the physicist is never going to get there, right? The engineer watches this for a day or two and says, it's close enough, right? So the idea that you're going to get transistors half the distance, you should have seen from the beginning that was only going to go for so long. And then
Sure.
Matthew did a good job of describing why are we at 7 nanometers, 5 nanometers?
7, I think. Yeah, we're at 7 as of 2020. Yeah, but I need to correct you. I'm not a theoretical physicist. So everyone always thinks that there's a difference between theoretical physicist and experimental physicist. I'm an experimental physicist, not a theoretical physicist. I build things with wrenches and screwdrivers, just like an engineer. So, except then I make fun of my engineer friends. I say, well, the difference is I understand how it works. Of course, I'm messing with them. I'm just messing.
Hey, Matthew, can you turn the gain down on your microphone just a tad there?
So is that the difference? So you said on episode 1 you're looking for dark matter and evidence of dark matter, and so is it the theoretical folks that are doing dark energy, or what keeps you from adding dark energy to your exploration?
Oh, what keeps me is it's just a completely different field. So it's a different skill set. So there's both theoretical and experimental for both dark matter and dark energy. Both. There's both of both. There's 4. So it's 4 ways you can do exploration, theoretical, experimental. The big difference is that you can't do dark energy in the lab. Well, there's some cute ideas. We need telescopes. But dark matter, you can build detectors. So I'm more of a particle physicist than I am an astronomer. Dark energy requires astronomers. Dark matter requires physicists. Both are needed. It's just different talents, different skill sets.
Okay. All right.
So, gentlemen, I have a very open-ended question that I'm giving to both of you, and I basically touched on it there in the introduction. We launched, and I say we, it was the Russians, but I'm talking about humanity. We as mankind launched Sputnik 1 back in 1957. We used ballistic propulsion technology to do so. We are now 64 years later down the road. We're still using ballistic propulsion technology to shoot things up into space. Why have we not advanced? What is holding us back? You
want me to go first, Matthew, or you want to go first?
No, you're the expert, and please go ahead.
I'm gonna say we're going to be using similar space propulsion techniques to get off the surface of the Earth or up out of any significant gravity well for the foreseeable future as well, right? So the physics of the challenge is, hey, we're stuck down here in this gravity well, and we got I'll call it a reasonably thick atmosphere. But what do I know? This is the only planet I've ever been on, so maybe it's reasonably thin atmosphere for all I know. That we've got to get through. And so we got to get through the drag of the atmosphere, get up above that, and then we got to accelerate to speed so we can stay in orbit. So that's the first part of the propulsion challenge, just getting up out of the gravity well and through the atmosphere. Where the advancements are going to happen in the future, I believe, is in space propulsion, where now so thrust is kind of a key driver initially, right? Getting up off the surface, and this isn't just Earth, right? Once we go to the next gravity well, and we got to get up off the surface of that gravity well, thrust will be a key driver, and plenty of the physics haven't changed. The material science, I think, is one of the big ones that's coming along, just not as expeditiously as I would have hoped. I thought we'd have quite a bit better materials by now. I don't know when the first time you heard about composites were, but and we're building more and more out of composites, but there's got to be a lot more we can do from a material science standpoint. And then some of the physics haven't changed and aren't going to change. And then the in-space propulsion, where thrust isn't as much of a driver, it's still a significant component, but specific impulse, or ISP, or gas mileage, if you're not comfortable with the rocket equation, becomes a big driver, right? If you're going to go on a long trip, the gas mileage becomes really important. And we do have some advances there well, I say advances. We probably had the basic technology in the '60s, but we just haven't pushed out and done it yet.
I know some of our satellites that we have launched, especially in the 60s and the 70s, they had nuclear reactors on board that were helping to give the propulsion of the craft, I believe. Is there a significant, other than the perceived safety issues with nuclear reactors and launching, chunks of uranium in space, is there any other reason that we're not using this type of in-space propulsion more?
Yeah, so I think I don't have all the space history memorized. I thought from the U.S. perspective, we've only launched one, and I think it ran for a little over a month, and then shut down for some other reason. But other than and don't let me trivialize this, right? Other than scaling up, no, we've had all the basic technology since the '60s to do what I'll call the first generation of nuclear thermal propulsion. So think maybe 900 seconds of ISP, where like the most efficient chemical engines are I think the space shuttle main engines, SSME, still have the record, and they're about 450 seconds roughly at vacuum thrust. And so nuclear thermal, I think in the '60s they were doing ground tests and getting up close to that 800 and change. And so yeah, and NASA is currently working on one that they want to test at half scale, design it for, I think they said 25,000 pounds of thrust, and build and do a in-flight test of one at half that size by the end of the decade. And they're hard at work doing that now.
Interesting. I was talking to one of our other physicists, a colleague of Dr. Szydagis is Dr. Kevin Knuth. And from my layman's perspective, I never knew. I guess I had never put brain matter to thinking about it. But when he was talking about our inability and humanity's long-term inability to ever even come close to the speed of light, and how we would have to spend years upon years just in an acceleration phase to even come close to that, that blew me away. I never realized that we have a 0 to 60 that is so slow. It boggles my mind that we would have to have, in order to have a biological being, a human inside the craft, and be able to survive the acceleration to get to near light speed, it would be lifetimes of acceleration just to get to that point.
Well,
And it blew my mind.
Not necessarily, Jeremy. If you have enough fuel, 1G is enough to reach the speed of light in 1 year. The problem is the fuel. So 1G is good enough to reach C in 300, 400 some days.
Really?
Yeah. Yeah. So I think you misunderstood, Kevin. Yeah. So yeah, that's just it's 300-400 days at 1G. The problem is fuel. The problem is that as you increase your speed, Newton's second law, even the rocket version of it, doesn't work anymore, because you have to modify your mass by gamma times mass, the Lorentz factor, which goes to infinity. And that's why you can't reach the speed of light. It would take an infinite amount of energy. So as you go faster and faster, instead of your mass acting like mass m, you act like you're 10 times, 100 times, 10,000 times more mass than you actually have. Like, I mean, your mass doesn't physically change, number of atoms in you, but as you approach the speed of light, your effective mass increases and goes to infinity. It's 1 over a square root. There's a vertical asymptote. So the problem is fuel. But yeah, no, I could write the equations for you on a whiteboard in a few seconds, showing you it takes 1 year to get near the speed of light. That's all it takes at 1G.
So if the problem is fuel, then things like this magic ion drive that I've been seeing, that's not supposed to work, but apparently it has a thrust output, and nobody can really explain why. Is that not a possible solution to some of these things?
I'm very skeptical. Maybe Tony knows more about it, but I've seen that most of the results I've seen are probably bunk. But don't get me wrong, I wish it worked, and I was gratified to see we're trying crazy ideas to try to break out of the current technology, but unfortunately it looks sort of like BS to me. I think it was just a mistake and misunderstanding. I don't think there's actually a positive thrust, and even if there is, it's minuscule. It would still be revolutionary because it would mean thrust without fuel, without chucking something out the back, the only way we currently know how to do propulsion. And so even if it was a tiny thrust, it would be revolutionary. But from what I've seen, I'm very skeptical because the results don't seem to stand up to scrutiny and reproducibility. And even if it did work, it's not going to get you near the speed of light. So what was amazing about the EM thruster idea was not because it was going to work to get you really fast necessarily. The amazing thing was it seemed to work sans propellant. No propellant, no fuel. It just turn it on and go, which breaks Newtonian mechanics and conservation of momentum. I still hold out a small hope it works, but I haven't seen any proof.
Tony, in your experience with NASA, are people looking at this type of technology and looking at it seriously?
Yeah. So I watched a tech brief from LSI, Limitless Space Institute. I don't know how old of an organization they are, but I just caught one of their tech briefs, and so they're funding some. Now that Matthew's schooled me already, I'm a little shy about guessing they're theoretical physicists. But they're building computer models, but that puts them on the edge there, right? That could go either way. But they're funding. I think they have a half a dozen or a dozen different projects looking at like the next century propulsion ideas. So I think they've got a little bit of fusion stuff in there. So I don't know how far out you want to put fusion. I'm not putting it in this decade without a gigantic step up in funding. So somewhere out there they've got a little bit of fusion stuff, but then they've got some other stuff. And I caught the brief. Most of it went over my head, so I reached out to one of my buddies who's got a PhD from Caltech, and he's like, "Yeah, it went over my head too." So it makes me wonder. Matthew, did you just say BS? So we're allowed to say that.
No, I did not.
I'm blaming. So I threw it out there that you said it, so I'm safe now. You said skeptical.
Yeah. But you mentioned LSI. Actually, a while ago, I would have agreed with you on fusion, but they just announced just on actually the APS, American Physical Society News, they finally at the National Ignition Facility at Livermore actually have a net positive energy output from nuclear fusion for the first time. So to me, that makes me confident that fusion is closer than we think. And also you mentioned LSI, and that's really great because that was something I wanted to mention eventually, is that there was just I believe today, or maybe it was a week ago, and I just learned of it today, that there was a brief from LSI where there are computer models, again, hasn't been built, but these are experimentalists, not theorists, so they're going to build it next. But there's some NASA folks, one guy, Harold White, who's a breakthrough propulsion guy, claims you can have faster than light travel, which would be obviously a huge step forward. Now, I'm very skeptical, but I'm also very excited because then we can skip all this, now, we don't need to talk about ISPs and impulses, just cut to the chase. And I'm very skeptical because that would be such a massive leap that I think I want to see him build it. Some of my colleagues, actually, Jeremy's colleagues, I forwarded UAPs, they're like, look, he did it. Everyone always reads the headlines and never read the article. Yeah. I read the article and it says potential to build it next year, which is still exciting, but not
so
done.
What exactly happened in this article? Because I read it, and Tony, I'm a technical writer. I take really, really cerebral ideas and I condense them down and I make it readable for like an 8th grade level, right? I read this article and I struggled with my understanding of how I would rewrite the article to make it digestible by normal John Q. publics.
It's not meant to be. It was a scientific publication.
Right. Well, and that's
Yeah.
also what confuses me, because
Yeah.
it's not a journal, it's not peer reviewed, and it's not, a published test. It's something that I've not quite seen before. So
No,
what did I read?
No, there is a publication. Are you talking about the article in the debrief? Or the
No.
publication?
No. The one,
Because there was a peer-reviewed publication which impressed me in European Journal of Physics C. So that's a major journal. I used to think this guy, I'll be honest, Sonny White, I thought he was a kook or a crackpot. I'm like, whoa, he's published in European Journal of Physics C. So no, that's a real peer-reviewed publication. So it made me take this seriously. But what he claimed is he's got a computer model of making a nano scale negative energy bubble that you would need for an actual warp drive if you built one in 50 years. So again, this is 50, 100 years away, but he's claiming that you could make a tabletop model now, today, this year. And if he's right, I'm extremely excited, but I'm very skeptical, because that would be a massive leap, especially into physics we don't fully understand, because general relativity and quantum mechanics, we don't know how to marry those two yet. And so I'm skeptical but hopeful. I'm balanced. Yeah.
So help me understand exactly, and I'm gonna try to condense this down into crayon for me.
Okay.
He simulated this, correct? He did the simulation,
Yes.
and the math lined up, and the output was that it could work.
Yes, so this is not theoretical, though, but like Tony just said, it straddles the line, because I do computer simulations all the time. Before I build something, I want to make sure it works. So this is not, so do engineers. So this is not theoretical. I can show you tons of theoretical papers on warp drive, and they're great, for fast light travel from theoretical physics. Bob Rick and Mateer, and then there's Eric Davis, who I really admire. But this is very different. This is a nuts and bolts paper saying, here is a computer simulation of something I can build in a laboratory soon with screwdrivers and wrenches. So it is a step forward. It is a big step forward, and I'm hopeful. But I think Tony's probably right that for the foreseeable future, it's going to be old-fashioned chemical rockets, because all these breakthrough ideas, the thing is, they're going to require a lot of time and effort and testing. And the old saying, you have to walk before you can run. And I do think I think it's probably too optimistic to think we're going to go from 17,500 miles an hour, what we do now, to, we got warp speed faster than light without going in between. I think that's naive. I think that we're going to have to, it's not necessarily linear, but we're going to have to take steps. We're not just going to jump ahead. I hope so. Hope we meet aliens who help us, like, hey, here's how you do it. But I think that Tony's right that for the foreseeable future, we're going to have, for example, we've got Elon Musk and Falcon 9 and things like that, and NASA's new systems. And I think that's going to be with us for at least a minimum another decade or two, probably more. So
Tony, when you're at NASA, when you're doing your training and everything, are they showing you projections of what 100 years from now that your grandkids are going to be riding on? Do they already have the imagery and the policies in generalities ready for the future of in-space propulsion?
Yeah, you guys hit on this a little bit in episode 1. They absolutely do. The problem is they change. The NASA's part of the government that rolls over, and one of the traits of our government, I don't know how strong it's been this way throughout history, but is you got to do something than whatever the last folks were doing. So they have them. They just keep rolling them in and out, and so some of that's happened with destinations. I think there was a time in history where it was frowned upon for NASA to say the moon, and another part in history where it was frowned upon for NASA to say Mars, from a human exploration standpoint. I think that the science and community kind of gets a pass, but they also they do a lot with the funding they get. Right, we've flown robotic scientific spacecraft to all the planets, and I don't know where we're flying a half a dozen around the solar system now, actively collecting scientific data. So they get a pass. But the human exploration piece gets shuffled. And while there's usually plans and policies for way out in the future, right? There's this political timeline and sense of what can you do in a politically relevant time scale.
So would it be safe to say that in order to have humanity achieve what humanity should be able to achieve in humanity's timeline, that we have to remove politics from it in an entirety?
Well, I just did my politic complaining side, so I'll take the other side, right? And one engineer and operator and program manager that I have a fair amount of respect for got up on stage at this big conference, and I don't think I was the one complaining then, like I just did. But he said, "Hey, look, y'all, if y'all want to go off and do space exploration, you're more than welcome to, and you don't have to worry about any of these political challenges. But here's the catch: if you're going to spend taxpayer money, this is how it works in the United States to spend taxpayer dollars. So if you want to go off and do it without the political restrictions, you might want to start selling books on the internet first." Well,
now we're talking SpaceX, correct?
Mhm.
Yeah, or well, and even SpaceX has now and throughout their company lifetime has gotten a lot of NASA dollars.
Sure.
Blue less so, but yeah. Certainly those gentlemen are doing a lot at their own pace, and so that they get a pass from a lot of the political. The two of them haven't changed their message from the first time I heard them talking about space, right? Bezos has been on moving heavy industry off the planet. That's the first space message I heard him say, and it's the most recent one. And Elon's been on colonizing Mars. I like his windows open, right? Why go now?
Yeah.
And his answer is because we can right now. The window's open. Hopefully the window for humanity to go to Mars stays open for forever. But it didn't for the dinosaurs.
Yeah.
Well,
that brings up a really, really interesting point, and I'm really glad that you mentioned the dinosaurs, because I want to kind of shift. I know you only have about a half hour left, but I want to kind of shift the conversation into what is possible. If we get rid of money, if we get rid of politics, and we just look at achievement, what is possible in our understanding of science? What can we do? What can we build? How long would it take? And the reason that the dinosaur link is in there is, if you would imagine, how many extinction level events has planet Earth had? I mean, right off the top of your head, you can count probably 4. There's probably
more than that.
Yeah, I mean, well, you sir could probably count a lot, but the normal person can think of about 4 main extinction level events, but there's probably been about 12 to 20 if you look at all of the extinction level events on planet Earth.
Mm-hmm.
So let's look at a civilization that maybe only had 2. Maybe they're the exact same age as we are, planetary wise. They're a Goldilocks planet. They supported life. Life started evolving around the same time that ours did. So they're not a super, much older society or much older civilization. They just didn't get wiped out 22 different times. So they were able to continue their evolutionary path. They were able to continue their scientific achievements. And, even though that they're still 4.6 billion years old as we are, their version of humanity is much older than we are. So they've created better technologies or more advanced technologies. And so let's kind of put ourselves in their shoes. What can humanity build without the confines of politics and money and the things that shut us down quite often? What are we capable of putting together?
Yeah, so we're actually pretty lucky with today's materials just to be able to get off the planet, right? If our gravity well was was much deeper. If our planet was either much bigger or much more massive, right, we'd still lack the capability to get into orbit. So we're kind of pretty lucky that we're just on Earth. Let's see. So we got that nailed, right? Since Sputnik, we've been able to get off the surface of the Earth. And then the next thing that, of course, we've had this technology since the 60s, and we're flying it in the 60s. We could do nuclear thermal propulsion. We could do it today with what I know about, I'll call it existing fission reactor design kind of stuff. So not waiting in the 700-second time frame of specific impulse. The answer to go to Mars with an efficient architecture is 900 seconds. So that's why NASA is pursuing a nuclear thermal propulsion test at 900 seconds of ISP. So they need to do a little bit of reactor development work, try to get fuels to be able to operate at higher temperatures to get that ISP. That's the targeted ISP for a Mars mission. That's been, I think, when von Braun was studying his architectures to go to Mars, it was 900 seconds. When NASA just studied it at the start of this administration, some of the physics don't change. The answer is still 900 seconds. We could do 7 and kind of brute force it. I'm convinced if we all thought it was important. And 900 seconds we can definitely do within this decade is my thought. But Matthew, what do you?
Well, my thinking is this goes back to what you had mentioned even before the podcast began about risk aversion. I don't mean human risk only. That's part of it too. Like, I think in episode 1, my saying was you can't forge Oregon Trail without catching cholera, diphtheria, whatever. So I think we're afraid of dying. And I have a brief story to lead into my answer. I signed up. I didn't make it. You know how there was like this go to around the moon with this Japanese billionaire, like the Dear Moon Project. I got so excited. I signed up and didn't even make the first cut. And some family members were like, "Oh, what if you die?" And I asked my wife that, and she goes, "Yeah, but it's worth it." So there are some things worth dying
Just
for.
because she has a hell of an insurance policy on you.
Well, no, that's not it. No, but there are things, but also risk aversion human. But there's another thing. My other second half, my answer, Tony, is like risk aversion. You brought up taxpayer dollars, okay?
Wait. Let's not leave risk aversion because I caught
okay.
that part.
Okay.
We'll go back to taxpayer dollars, but you're onto something here. But I think you're being too kind.
Too kind?
Too kind.
Okay.
It's not just risk aversion, right? It's poor risk benefit decision making or zero risk leadership. And I was remembering a study that I saw. I believe it was a really small study. And it was too long ago, but I got to believe somebody's doing it again, where they looked at reaction times and controllability and stuff of legally drunk drivers. It was on a test course, and they got them right up to the legal limit, and then they had reading text messages and then sending text messages, and it turns out just reading text messages while you're driving puts you at the same level as just over the limit for legally driving under the influence.
I believe.
And so when I see stuff like that, I'm like, I believe in most places the penalty for DUI is much more, and rightfully so, is much more is harsh, but it's much more severe than reading a text message while you're driving. And so there's folks out there that are telling you they're afraid to fly in space, and they're driving around.
50,000 Americans die in a car every year.
Yeah.
No, you hit the nail on the head.
We're not doing real risk leadership decision making.
No, Tony,
we're just picking
really
things that we don't want to do and saying, "Oh, they're too scary."
No, you hit the nail on the head, Tony. I'm so glad you said that, because as humans, we're very poor at calculating the risk to benefit ratio. I'll give you it'll be a controversial example, but Jeremy's not afraid of controversy. So I read this in the New York Times. I'm going to preface this as this is not from some conspiracy theory blog. because of the fact that I had COVID and I have 3 shots of Pfizer and I have a positive antibody test, I am way more likely to die in a fatal car accident tomorrow than I am to die of COVID-19. And yet the terror and the variants and this, even though you're counting the variants, I am way more likely to die of a car accident tomorrow morning on the way to work than I am of dying of even the Omicron variant. The thing is, people don't know how to do risk benefit. If the risk is weird and the risk is new, and space travel is still new, even though it's been with us since the 50s, people don't understand how to do that calculation. They think space travel is dangerous, but like you said, they get into their car and the 50,000 Americans die a year in a car, which is 1/10 the number that die of COVID. So that's still much worse, but that's still a significant number. 50,000 Americans die a year in car accidents. But the second half of my answer was also risk aversion, but I'm glad you interrupted me because that was a really good extra point you made. But there's a different kind of risk aversion, monetary aversion. I'm not talking about human safety now, but monetary risk aversion. And I speak from experience here because I have a stack. I'm very lucky that I do have funding for my dark matter experiment from the Department of Energy, but I have a stack from the last 7 years this high, and I'm not exaggerating because each government proposal I do is hundreds of pages, right? And my colleague Kevin has a stack even higher of failed proposals. Why? Because they say, oh, we can't spend taxpayer dollars on this because it's too risky.
Yeah.
And what they mean by too risky is it might not work. Guess what? That's science.
Right.
That's the definition of science. Like I said earlier, the EM thruster, it looks like it's BS, as Tony said. But you know what? I'm glad we tried, because what if it did work? And I think the problem is we're afraid of spending money and taxpayer money and taxpayer pay of spending money. Basically, I'm caught, and many of my fellow scientific colleagues are caught in a catch-22 where to get money, you have to prove it works. You can't prove it works until you get money, and it's a chicken and egg problem. And recently, it's gotten disgusting. The last 10 years has gotten out of hand, where DOE, NSF, no one wants to spend money on some crazy idea like faster than light travel or this. Everyone's like, no, let's take baby steps and keep building more rockets. And I'm glad we have LSI, as Tony mentioned. NASA is taking some risks, but I don't think it's enough. And that's
let me ask you guys this: if in that axiom is absolutely true, you have to have money to be able to prove the science, but they're saying that you have to be able to prove the science to get the money. So that brings up a very pointed question for me, for both of you, actually. The Salvador Pais patents, the U.S. Patent and Trademark, they actually patented a mass reduction spacecraft, something that, if you're familiar with the Tic Tacs that occurred with the USS Nimitz and the USS Princeton and their flight characteristics and the things that Commander Fravor and Alex Dietrich were saying, how these things were flying, the flight characteristics described in these patents mimic that of what was described to us with the Tic Tacs. So where did the science come from if you have to prove it works first to get the money? Where did that science come from?
No, there are exceptions. If you work for DOD and stuff, then you don't need that step. I don't work for DOD. No, I said before, those patents are BS, and I know there'll be defenders of Pais who will be screaming in the comments on this video. They're complete garbage. I dare someone to prove that wrong. Build it and show me, okay?
Well, I'm sure Tony would probably love to fly them.
I know, but it's junks. It's not just me. I've looked at the patents with my colleagues, some of them much smarter than me, who looked at it and like, yeah, it's a crock of shit. Like it's complete nonsense. And I mentioned in episode 1, my hypothesis is that was a placeholder where they're just making stuff up that they thought sounded might work, but it's utter nonsense. I would much rather believe the faster than light thing, that because it's published in a real journal today, like than that nonsense. It's complete garbage. I mean, it wouldn't even work at all. None of them work.
What about in your circles? Do the folks in your circles look at things like the Pais patents and go, what the hell was the USPTO even thinking when they published this? I mean, is it, or do they just look at it and they're like, I'm not even going to waste my time with it? Or do people look at it and say, holy crap, what happened?
I think I think it was the middle one. The folks that I know looked at it and went, yeah, what's the patent office doing? I should write down some of my crazy ideas and send them in. Apparently it doesn't. There's no requirement for any of it to work. So
Yeah, I personally think that the patent was written in such a way that the patent clerk that was reviewing it and looking at it had no idea, was not qualified to even run the basic math, and was like, "Damn, okay, check, and hit print." So I
yeah,
don't think
or
Those
it doesn't have to work to have a patent, right? It's
Yeah.
like, hey, no one
No.
else has sent this in yet. Go for it.
Yeah.
Yeah.
And
What's their actual check? What are they trying to decide before they issue a patent?
Yeah, and to this day, I'm incredibly frustrated. I can't find. There was a website. I know I read this article because I have a photographic memory. I know I read this article that said Navy admits the patents are bunk. I read this article, and now I can't find it anymore. It was on the War Zone or the Debrief, and it's very Orwellian. But they
Yeah.
freaking deleted it, and I read it. I have a photographic memory. I know they read the article. So the Navy at one point said, yeah, we admit it's BS. And then, no, I remember the last sentence of the article was Pais saying, well, yeah, it still works, darn it. It's like quoting him.
Well,
It's
he's
like,
still employed
yeah.
by, I think
Yeah,
he's
he is,
employed by
yeah.
Lockheed, isn't he?
Yeah, I believe so. Yeah, no,
Yeah.
yeah. So look, don't get me wrong. I would like nothing more for even one of his patents to work. I want to be
Sure.
proven wrong. I'm not some jerk with an ego. I want to be proven wrong. I want him to prove me wrong and build it because that would be great. But I actually looked at the science deeply and read the math with my colleagues. The math is a joke. It's a pseudoscience. It's pseudo. It's ridiculous. Yeah.
So Tony,
Yeah.
take me 100 years into the future. What does our spacecraft look like 100 years from now? Are we approaching Stanley Kubrick in 2001? Are we looking at Star Trek, or are we more utilitarian and we're still, maybe more like the Expanse type of ships? What are we flying 100 years from now?
Yeah, so a couple of caveats, right? These answers are the exact same as they were in the 60s, right? Von Braun knew all this. And so until we have a real impetus to go, I know a couple of the Apollo folks, one of which I won't mention his name on here, but we were having breakfast and then we were talking throughout the day, and I'll, as politely as I can, refer to him as a grumpy old man. He was just being grumpy, and I was, young and excited, not that young, but super excited. And it's like, we need to send humans to explore Mars. And all my ideas, he was just shooting them down. And he's like, you want to know why we were able to get to the moon? And I'm like, okay, you shot me down over and over. I'll just shut up and listen. And he's like, because it was fear. Like, we were afraid. So fear's a great motivator.
Sure.
Man, I'm a pretty optimistic person, and I gotta hope that we can do great things for some reason other than fear. But we need the impetus. So otherwise, we're going to be as many years as we are from when von Braun was putting all this together to now going, this is all we've done so far, right? So I talked about nuclear thermal propulsion with fission reactors, right? We could do human exploration of Mars in this, with basically today's technology. So as soon as we gather up the resources and the will to go do it, we can do that. Fusion, right? Fusion for power. So like a fusion reactor for electrical power, and or fusion propulsion. And that is, I think is, Matthew, whether you call this today's physics, but not yet today's engineering. Is that a good way to characterize it?
That is a great way of characterizing it, because, for example, nuclear fusion, we know the physics, but there's a lot of engineering challenges. So how do you make a fusion reactor stable and you don't have neutrons transmutating the elements of your reactor? Those are not laws of physics challenges. Like warp drive and those things are more serious. They're laws of physics challenges.
Yeah.
This is more like we need clever engineering to find loopholes. to make it work within the known laws of physics. Yeah.
And
So
is this a
then I think-
limitation on the way that we're thinking, or is this a limitation on
No,
the
material
the
science.
computing power that we're using to simulate the designs?
Yeah, so the first one's the money, right? I contend with enough money, right? So that gets you the right people, the right computer simulations, and if you're going to go to quantum computing, of course that'll make everything a whole lot more efficient. Being able to analyze these different things with I'll call it parallel processing for lack of a better term, quantum level parallel, like everything at once, not just two or three. But if the physics is understood and it's just an engineering challenge, now it's just the will to go and the resources, right? And so I think we can, and with that technology, we can explore this solar system, right? We can send robots and people to any of the moons of Saturn or Jupiter that we want to go investigate. Certainly Mars. We can go in. I've seen folks with ideas of floating around in balloons in Venus's atmosphere. I'm not sure I see all the advantages of that, but wherever you wanted to go, right, with that kind of fusion propulsion, right? So for electrical power and or a fusion engine, and that's physics that are understood, but engineering. So with enough money, you can develop better materials. You can do all the simulations and processing and design stuff. So I think of that as doable. How long it'll take? It'll take forever until we get the will to go do it. And then go ahead.
I agree with Tony go ahead, Jeremy.
Yeah. So in my technical writer mind, and forgive me if I'm misparaphrasing you on this, you're saying that it's going to take two things for humanity to advance past our current propulsion tech. It's going to take the advent of quantum computing to be able to better, faster, more design the engineering and the processes and look at the simulations. But even more importantly than that is we have to find a reason to go. And in the space race that we went to the moon, the impetus was fear. It was the fear of conquest from the Soviet Empire. It was the fear of falling behind and not being a leading world power. Is there anything other than fear that is going to push humanity to be able to make a huge achievement? Or are we forever going to be ruled by the universal limbic system?
Yeah, I think Elon's going to go. He's just got to continue to go fast, right? There's the whole fortune favors the bold. He's had the company, the team has had a whole lot of challenges. They've just keep going, and they keep going fast enough that most of their challenges end up in their wake, right? They've blown up their Dragon spacecraft on the pad testing hypergolics, but they were already moving and improving designs even before it happened. They lost a rocket in first stage that was a resupply mission. Engine issues. They lost a rocket on the pad, but they're continuing to go, and they're going fast. And what they're doing down in South Texas with Starship, they got plans to have that thing in orbit. I know he said something about funding and stuff, but that you got to be rooting for him to keep going fast. So and he's not doing it because he's afraid. He's able to generate the necessary resources, a combination of himself, his investors, and then whatever he can get from doing work for the government.
Now, Jeremy, you asked me, Tony, and I about number of years away. I have to remind you, though, Tony was right with it's the same as the 1960s. I wanted to drill into Tony's point there, because remember I brought this up in episode 1. Let's go back 50. Let's not take it to 100, but 50 is often a number you throw on as well, Jeremy. Go back in time 50 years and imagine asking people, oh, can you imagine airplanes 50 years from now? Who would have imagined they're the same
Yeah.
damn thing? And
Actually,
where's
they're
the
worse because
supersonic teleportation? They're worse
yeah,
because now you sit like this when back
yeah,
in the day it was luxurious.
and I have
even for
plastic
economy. Yeah.
forks.
Yeah, exactly. So the problem I have with asking number of years, Tony really hit it with it was the same when von Braun was around. It's the problem is until someone decides until we have the willpower, as Tony said, we are stagnant. Air travel has been stagnant for half a century. Frankly, it disgusts me. I'm glad I read United's bringing back supersonic travel. I'm like, finally, it's the 21st century. Where's my flying car? Where's my hoverboard? Like, it's just, it's, and the problem is the stagnation is due to not just risk aversion, it's risk benefit analysis. And like Tony says, willpower, money. So it's not just one thing, it's a multi-factor thing.
But
and the impetus. We don't have a force pushing us to make that achievement, to make that advance.
Because you mentioned fear. But you know what? The current situation is a great example. Take the COVID-19 virus and make it 10 times more fatal. We'd be pretty damn screwed because we're a one planet species. If we want to survive pandemics, asteroids, volcanoes, human-made disasters, war, nuclear war, World War III, we better become a multiplanetary species. So if you want fear as a motivation, there it is right now, what if the next pandemic is 30% fatality instead of 3%? We are screwed if that happens.
Well, on the topic of fear, Tony, let me ask you this, and we've got about 10 minutes left of your time, sir. I'm sorry. With the topic of fear, and I know this is a loaded question. We haven't discussed it much. We've kind of hinted and tap danced around it, but what do you feel? I'm not asking you what you believe or what you know, but what do you feel about the existence of other civilizations? And if you believe that they exist, do you believe that they would be a threat, or are they malevolent or benevolent towards humanity? Or have they never been here? Or just give me your thoughts on that.
Okay. Yeah. So, yeah, I don't think they've been here in any way, shape, or form. And we were sort of talking around this earlier, Matthew, but I admit to school children all the time, right? I do not understand really small numbers, and I do not understand really large numbers. And oh, by the way, I don't think I'm alone in that. I think the physicists might be the only group that understand either one of those, and maybe a couple of people understand both, right? So when you look up at the night sky, there's a large number of stars, right? By large number, I mean a number that I don't really truly understand. With our satellites, we've discovered enough planets around those stars. This came out, I don't know, a year or two ago. Somebody wrote down, hey, we've discovered enough planets to be able to guess that there's a planet around every star. And I'm like, hey, I consider myself a pretty average person. I feel like I grew up in a pretty average solar system. So I'm going with 9. I'm a Pluto fan. So I'm going that there's 9 planets on average around every star. Maybe I didn't grow up in an average solar system. I don't know. But it's the only one I know, right? So I'm going to go with what I know and say there's 9 planets around every star. And so now the number that was large gets multiplied by, another order of magnitude. Mm-hmm. So I wouldn't be surprised. I feel like there's life out there, or has been or will be, right? Because we're just in this little window of time. And I was watching a presentation years ago about, looking for Earth 2.0, right? Wouldn't that be grand? They said, look, if you looked back at Earth throughout our history, we haven't looked like we look now. Sorry about that. I don't know if you can hear my dogs in the background. I apologize.
No, you're fine.
We haven't looked, if you were looking at Earth from far away with the telescopes that we have now, right? We haven't looked like we look now for very long. And if you would look through our history, and go look for Earth 2.0, there's only a relatively small window where we've looked like we look now, and you would think, hey, that's what Earth is like. And so, of course, the light or the energy we're collecting from these telescopes isn't now. So who knows how far away that stuff has come, and when that data was actually generated before we collect it here on Earth. So there's just too many chances out there, right?
So I can add to that, actually, my colleague, Professor. So I have to correct you on a few things there. It's actually much bigger numbers than you thought. I hope I claim to understand big numbers. So we've actually
I got 10 to the 21 in my head.
That must be for the entire universe or something. That's bigger than what I was about to say. But yeah, for our galaxy,
but I don't know what that means. I mean, I know
I'd have to think about
big,
is that number of planets in the universe? Could be. I mean, that is such a huge number. That's even beyond. That's only in the visible universe. The universe could be infinite, though. But in our galaxy alone, you were talking about the planets that NASA has discovered with the exoplanet missions. My colleague Kevin works on exoplanets, so I know these numbers. So it's actually bigger than what you said. So we discovered, I think, about 8,000 exoplanets in one tiny portion of the sky. Yeah. Now you extrapolate to the entire galaxy, it's probably several trillion, not billion, because like you said, multiple planets per star. But it's even better than that. So there are several trillion planets in the Milky Way alone. That doesn't count moons. Okay, each of those planets could have moons. And then you multiply by 9. We don't, by the way, do you realize we don't have to do that anymore? We've discovered hundreds of star systems. So actually, I don't remember off the top of my head if 9 is an outlier or typical. We've discovered star systems, not just individual planets. So some star systems have 2 planets, some have 5. My understanding is that 9 seems to be an outlier large, but I think that's probably artificial, because our detection techniques are not refined enough to catch every planet. So my understanding is the systems we've seen are like 3, 4, 5 planets, but I think they're probably an underestimate. So sure, we could use 9, but then multiply by the
That was the part I left out, right?
Yeah.
That was a moment in time. And so at one point in the past, we had gotten that much data. Guess what? We're never going to discover fewer. Right, so we're only adding to this number. There's no subtracting, right? So it's
well, no, there's subtracting if we make a mistake and it's not a planet; it was a glitch.
Well, you brought up moons as well. I mean, we're pretty sure that Jupiter. We're pretty sure that Jupiter cannot support life, but
Europa could.
Europa or Io, absolutely they could. So and that's in our own solar system. So,
but this is going to blow your mind even more, Tony. I'm not sure maybe you've heard this before, but I learned from my colleague Kevin. You could look up at the sky tonight. Okay, the odds are. So the odds are 1 in 5 stars you see, so 20%, have a planet in the Goldilocks zone, with the potential for liquid water, potential, not proof, because it could be, like we were just saying, Earth has looked different. Billions of years ago, it was definitely not inhabitable, except for the single-celled organisms. So we have to be cautious about the statement, but 1 in 5, look in the sky tonight, 1 in 5 have a potentially habitable world. To me, the odds are massively in favor of there being life forms. Now, it's another leap to say they can do space travel and they've already been here. That's more difficult to prove or to argue. But to my mind, it's been proven beyond a shadow of a doubt that life is likely and that the conversation has changed thanks to NASA missions like Kepler and TESS, I believe is the new spacecraft, and then James Webb is going to look for exoplanets. I think thanks to NASA, it's completely changed the conversation. To me right now, someone who says we're alone, that's the extraordinary claim that requires extraordinary evidence for me. I'm like, really? With all those planets in our galaxy alone, really? You're going to say Earth is... I mean, it's true that life is probably unlikely to form, like it's very, very improbable. But if you take a small number and multiply by a really big-ass number, you can still get a finite number. And you could multiply the tiny probability of life forming times all those planets using something like the Drake equation, modified Drake equation, and you can get answers of like 10, 100 civilizations out there minimum as a conservative estimate. And so that's my thinking.
So
that's
Tony,
why I started with I don't understand big numbers and I don't understand small numbers, right? Because
but if you multiply the 2, you get medium size numbers.
Well, Tony, I'm going to get
December 22nd. So James Webb is scheduled to launch from French Guiana
Nice.
on December
Awesome.
22nd. So let's hope that goes off. We got the scientific community's got a lot riding on that mission. So
Absolutely.
we gotta get that up and
orders
on
of
the way.
magnitude better than
And
Hubble in more
you-
ways than one. It's going to be amazing.
Matthew and Tony, correct me if I'm wrong here, but I think I remember watching Tony do a spacewalk and fidget with a screwdriver, getting Hubble back online. Am I mistaken
was
in this
you?
memory?
No, that wasn't me.
I could have
I
sworn
haven't
that
been to Hubble. I haven't been to Hubble, and I haven't done a spacewalk. So
Really?
it definitely wasn't me.
Why did I think that
my
was you?
missions, both my missions went to the space station, and
Okay.
it was during kids regularly ask me about the science that we did on the space station. I'm like, it was primarily a construction mission. We did some science, but we were basically just construction workers putting that thing together. So,
Well, I'm going to get all conspiratorial on you just for one minute here, and then
all right, go for it.
I know your time is limited. You've got to bounce, but and this has been sent to me. This is not my question. This was emailed to me, and I have to ask it just based on the person that sent it to me. If there is no such thing as current proximity of aliens or spacecraft around the planet Earth, why does it seem like NASA always cuts the live feed right when something appears in view? This is the conspiracy theory that people are saying, they see whatever it is, it's a loose wrench or a blanket or something that looks as if it could be moving and then changing direction, and all of a sudden the live feed from the ISS just goes blank. So it feeds into the conspiracy theory that NASA is watching this and they're pulling the plug whenever there's something that they don't want us to see. Why does the live feed stop?
All right, I'll see your conspiracy theory and raise you one.
Okay.
Is there anybody out there that actually watches NASA TV?
Oh yes. Oh
Are
yes.
there?
Yes. Yes, there
I didn't even know.
There. Yeah.
I got a silly story. I'll save it for another day about being on NASA TV early one morning. Actually, now that I think about it, I got a few silly stories about stuff on NASA TV. Nothing to do with unidentified flying anything. I think you might. It is either. I'm gonna go with sheer coincidence, because I've watched plenty of NASA stuff, and it's pretty rare to see anything exciting. Like the launches are exciting. The spacewalks, if you're understanding the task and have trained for them or are doing them, are really important. Great work. But because you have to be careful, right? You don't have a spare of hardly anything. And you're only going to get one chance to do this particular job, so you got to do it slow and careful and double check everything, which just makes it take a really long time. And I can't think of any scenes that I've seen that were getting exciting that NASA intentionally cut from. But you can watch the board in mission control and see the AOS, LOS clocks. So, of course, the communication link as the station goes around the planet is switching from TDRS satellite to TDRS satellite. And sometimes, depending on what's going on, NASA doesn't even book that time because they have to pay for it. If there's a spacewalk going on, they book all the time. But other times, they don't even book that coverage. So NASA will lose a signal from the space station just because of communication stuff.
Fair enough.
That was my first job as an undergraduate, was actually doing computer programming for a TDRS satellite for a South Pole telescope mission astronomy. So when you said
was
TDRS,
it expensive to get the TDRS time?
My mind's actually, I don't remember. I don't know. That was above my pay grade. That's what my boss did. I just did the computer programming. So you'd have to ask my advisor.
Well, Tony, before you leave, when UAPX goes out on our next expedition, which I can't say the location, being as you are of the mindset that they're not here and they haven't been here, would you like to join us for an opportunity to potentially either maintain that mindset or radically change your personal position? Would you
My
like to come
view,
out with
yeah,
this?
yeah. Let me know where and when, and I'll check my calendar. But
Perfect.
do I have time for one ridiculous story that's got nothing to do with
Absolutely.
space?
You have all the time in the world. The hard stop
All right.
was on your schedule, so stick around as long as you want.
I probably shouldn't finish with this one, but here I am starting it, right. So Matthew on episode 1 mentioned no one's ever come forward and said, "Hey, I flew the Tic Tac." So I'm not doing that. I didn't. But then Jeremy, you mentioned that the military spacecraft have the ability to turn their lights off, right? But then you stop there, and I have flown some Air Force airplanes. But just handfuls of hours.
Sure.
Not like the Navy airplanes that I flew that I've got more time in. And the Navy airplanes on the aircraft carrier taxi around at night. Well, day and night, but it doesn't matter in the day. At night with all of their lights off.
Mm-hmm.
And in the daytime, when you're on the catapult ready to go, you run your engines up, you check out everything, you check out your flight control system, and then you salute the catapult officer and they launch you. At night, you turn your lights on. And if you've got your lights on anywhere, anytime other than that, it's a signal to the flight deck crew that you've lost your brakes. So hopefully they'll roll a tractor or some equipment or some young sailors in front of your airplane to stop it before you go rolling off the
Human
flight
speed
deck
bumps.
to your demise. And so the Navy carrier-based airplanes, in addition to being able to turn their lights off, can turn them all off with a single switch.
Mm-hmm.
So you can turn them all on and adjust the rheostats to get all the right brightness for them individually, and then you can turn them all on or off with a flip of your pinky.
Yep.
And then I don't know if you've been to the Panamint Valley or the Saline Valley, just west of Death Valley. There's a
I go out there and take I do astrophotography, so I'm out there quite a bit actually.
Yeah, so if you next time you drive through the Panamint Valley, it's like one road. Once you get north of Torona, pretty straight for miles and nothing around. And I may or may not know somebody that was flying an F-18. And oh, by the way, when you light the afterburners at night, right, they draw out big, giant, bright flames. So you can turn all your lights off, go rolling at or from behind somebody driving through the desert in the middle of nowhere, which has got to be as quiet as all get out. Light the afterburners, flick on the lights. You've got bright lights, strobing, flashing, twirling, big flames coming out the back, noise, rumble. And then you can pull it out of afterburner and flip that pinky switch off, and you've just disappeared. So while I've never flown a Tic Tac, I may know somebody that's been suspected of going, wow, I don't know where that came from, but I've never seen anything like that on this planet before.
Nice. Yeah, I go out to Ballarat, which is an old ghost town out in the Panamint Valley, and I do astrophotography out there. So there's been occasion.
Ballarat in the late 1990s, there was one store, and if you could drink a beer with the mayor.
Yeah.
And you'd walk into that store, and the old timer behind the counter would say, "Hey, do you want to drink a beer with the mayor?" And of course, there's only one answer to that. Absolutely. He's like, "Go get two out of the fridge," because
he's the mayor.
Yep.
Absolutely. What did you fly, Tony?
Primarily F-18s.
F-18s,
operationally
okay.
and test, yeah.
And I'm sorry to keep you, but I've got to ask you, you've never seen anything that you could not explain while you were airborne, or have you?
No, I've seen plenty of stuff that I couldn't explain. From the ground, I saw what I gotta guess was a rocket launch out of Vandenberg, but it didn't seem like it was. We were looking towards Vandenberg, and it didn't look like a rocket launch. It was the weirdest thing. I have no idea what it was for real. You guys were you talking about Venus last time?
Yeah.
I don't know how many times, you're trying to find the tanker and you end up trying to rendezvous on Venus, which doesn't work well on an F-18. So you see stuff all the time in the Gulf.
Mm-hmm.
The combination of the oil rig fires and the stars, and I don't know if it was smoke or haze or whatever. You'd be flying around the Gulf trying to get back to the boat. Some days you couldn't tell whether you were right side up or upside down with all the weird stuff you were seeing, just lights and everything disorient.
Yeah. Yeah.
Dis.
So
I don't
it's
even, I can't even say, I'm so disoriented. I can't even say the word.
have
But
you?
I just never, I never guessed that one of those wasn't just something playing tricks with my mind.
Sure, sure. In your mind, is it possible? I don't want to plant a statement, but is it possible in your mind for specifically an FA-18 pilot to look out the cockpit window in a high stress environment and see something that is there, but completely misinterpret the visual clues?
Yeah, so I know you guys were talking about sex in the first video.
Yeah.
He was a neighbor of one of my department heads. This was before. This was when I was on the Nimitz, and I don't know what air wing he was in at the time. So I've had a beer with him at a pool party, but this was before. But he had what, the FLIR was tracking something.
If now Gary Voorhees is more the expert for this story than I am. I believe that when Fravor was up, he came back down and he sent out the next crew, the junior officer, to go up, because I believe the junior officer was the one that actually had the pod. I don't think that Fravor had the good pod or had a pod. I don't honestly remember exactly what the equipment loadout was.
That's a really true part of the story. The Navy never buys enough training equipment, so it doesn't surprise me one bit. If he had a pod, it wasn't working, or he didn't have
Right.
one. They put one pod on every other airplane or something. So that part's completely believable. But yeah, with the FLIR track, it's harder to guess at what it was. Likely something flying around, chances of it being a reflection of something in the IR spectrum, I'm guessing is pretty slim. But countless times the E2 and the AWACS and the ship's radar would vector you off to go chase somebody down, and you get there and there's nothing there. We used to joke that we were trying to chase down Elvis. But the FLIR is interesting, right? What was the FLIR tracking? Would it track a IR reflection, and what reflects IR energy? I don't know. I'm just not going to guess it.
Yeah, it's a weird thing, and I will tell you, Tony, that UAPX is not a sophomore attempt at any of this. I mean, obviously we have Dr. Szydagis, Dr. Knuth, we have people that are working on dark matter projects in the Philippines and things like that. We have an exceptional collection of people and an exceptional collection of equipment, and I can't say much because of current NDAs that are in place, but very soon some of this will be coming out, and you'll be able to see, the world will be able to see the corresponding data that we have gathered with visual tracks from disparate equipment that all back up what the visual image is showing. And it's mind-blowing. I did not think that, because we don't have just a FLIR pod and testimony. We've got equipment that 20 years ago the United States government would have been jealous to have, or they do have, and they've never told us that they've had it. So,
like adaptive optics in the Navy.
Yeah.
So
I don't doubt there's strange stuff lying around, especially now with drone technology. I will tell you this though, having been up off the planet just a little bit and circled the planet, if I was coming here from far away, I'd be in the Caribbean. Well, of course, we were only inclined at an inclination of 51.6, so we weren't going over the poles or anything. But 51.6, you can see a good chunk of this planet, and it doesn't take you long to go, ooh, I want to go hang out in the Caribbean. So if all the sightings were in the Caribbean, I'd be like, oh yeah, of course, that's the most beautiful part of our planet. So no wonder they're all crashing in there trying to get to the awesome beaches. So if I'm gonna visit a new planet, I'm going to the prettiest spots, and I'm convinced that's the Caribbean. So if you're picking up the signals there, then definitely call me up, because it's a likely contender.
That makes a lot of sense. I tell you what, if we can get you on board and have an extended conversation, maybe we can pull the funding together to get us all over to the Caribbean.
Well, I think it's nuclear silos that attract them, though, allegedly.
Yeah,
Right?
there's a huge correlation between nuclear missiles, nuclear technologies, and UAP sightings. So it's really interesting stuff. I would love to be able to bring you behind the scenes, Tony, and show you what we've got, because I think I love the fact that you are in my terminology optimistically skeptical. So you have an open mind, but you've not been convinced that anything is here, has been here, or is in close proximity. So I would love to be able to show you some of the stuff that we've collected to see how you react to it, because I'm not a scientist, but it's mind blowing.
Very cool.
So, Matthew, do you have any final questions for Tony before he has to bounce out?
Tony, do you have any optimism towards, given what I mentioned earlier, some of the breakthrough stuff that's happening, like this alleged breakthrough for warp drive, things like that? Do you really think we're still stuck with known physics? When, I mean, one thing that bothers me, Tony, is that general relativity is now over 100 years old, and we've yet to capitalize on it for propulsion. I mean, Newtonian mechanics is great, but it's several centuries old. We know it's wrong. I mean, it's good enough to get to the moon and Mars, but it's an approximation of general relativity. And if we could somehow warp space-time, I mean, it would be probably really hard, obviously take a lot of energy, but do you have no room for optimism that in 50, 100 years, we, instead of the things you mentioned, will do much better?
So three buckets, but first, are we using general relativity to kind of make the precision corrections on GPS? So
yes,
we're using it.
Yes, we are.
Not 100 years old. We're not not using it at all, right?
No, you're correct. You're absolutely correct. We do have a practical application. GPS satellite requires both special and general. Yes, you're absolutely right. But it's a small it's a small effect. It's a small correction.
Right, you got to start somewhere. Okay,
we do,
so like I said, I'm optimistic, right? I'll even find uses for. So three buckets, right? One, I'm big on the impetus, right? I want us to land a human on the surface of Mars and bring him or her back to Earth. I've seen Earth from low Earth orbit. I've seen pictures of Earth from the Apollo program, and talked to some of the folks that took those pictures. I've seen pictures of Earth from the surface of Mars that a robot took. When I see Mars in the night sky, she looks like a star, right? And until you really look, when you see, like high-rise images from MRO or the pictures from the rovers, you can tell she's a planet. Mars is a planet. But what I get to do in my lifetime, because you've seen pictures of Earth from low Earth orbit, and I'm convinced, of course, you live on a planet, but you don't feel like you live on a planet like you would feel if you got to see Earth from low Earth orbit. What I'm curious about is, what does it feel like to stand on the surface of Mars and see Earth in the night sky, right? It'd be like, oh yeah, it looks like a star. Yeah, it's a little pale blue. Yeah, you can sort of see that. I don't think a human ever anywhere will look at Earth and not think that's home, That's where everybody is and lives. I hope they're doing well. I hope I can get back there, right? So I want to hear from the person that walk, or people that walk on Mars, come back and tell me what it feels like. Tell all of us what it feels like to look at Earth from that distance. We can do that with today's technology, right? With the physics and engineering that we could produce together. And the folks in the 60s could have said the same thing, and we haven't done it yet. So, and I'm not, my window of time to get to hear that person tell us what it feels like is closing. So that one's first, because I want to see it happen. The fusion piece and exploring the rest of the solar system, right? We understand the physics, and I'm convinced we can solve engineering challenges with money, with effort, with desire, right? We just got to go do it. And so I'm hopeful that we'll do that. And then the next piece, right? The wormholes, the whatever waves to travel faster than the speed of light. We don't yet understand the physics. So I don't think you can understand physics with more money, right?
You could actually. Let me tell
you
you.
Could,
if you
do
gave
it
me
faster.
more money.
Yeah. So I'm hopeful we'll do that. I don't know how long it will take.
It might surprise
and what
you.
other things will go along the ride. I'm all for setting ambitious goals, because we're going to learn countless things. I mean a lot, not just because I can't count very high. We're going to learn countless things by trying to do something like that, right? By pouring our efforts into traveling outside the solar system. I just don't expect to be lucky enough to get to see any of that. But no, I'm optimistic to think it's going to happen, because the only other choice is we end up arguing over something that we're probably already arguing over now, and it's not worth our time as a species. I don't know what the argument is of the day or year, but it's small compared to exploring the solar system, right?
Yeah. Did low Earth orbit, did it change you, like emotionally, religiously, or some people feel very changed seeing the Earth?
Yeah.
Yeah.
Yeah. One of my first thoughts, and I remember thinking, you would think as much as money as the Navy and NASA spent training me, I would have been smarter than this. But I got up there and looked down. You go around the Earth every 90 minutes, and you're just like, that's it. And I remember thinking, that's where everybody lives. Like, not like some people, that's where everybody lives. And you can go around it in 90 minutes.
Well, 88
and I tell
minutes.
school
I
kids,
just had my students do the problem. I just had to
What's
message
that?
you. It's 88 minutes. I just had my students do the problem.
at what altitude, right? If you go to GEO,
160 kilometers, it's 88 minutes. Yeah.
Oh no, we were above 100. We were above 200 miles. So
I said kilometers though. So
yeah, so you're
you said
faster,
miles.
lower.
Damn it.
You're faster,
400. I think
lower.
I meant 400 kilometers. You're fast. You're
Matthew,
faster.
you're going to owe Tony a
400
beer before the end of the day.
No, 88 minutes to a naval aviator. 88 minutes, 90 minutes. That's the same. Oh, by the way, I just saw the station ducked out of the way of was it a Pegasus upper stage?
Yeah. There was, that was,
and they
that
went
was
down.
sketchy.
So you go, that's a tough way to use propellant, because you got to
Go back
regularly use it to boost back up. But what was I gonna say? Yeah. So what did you say? 88 minutes? You can go around in 88 minutes. And I tell school kids that's like all the good guys and all the bad guys. I'm like, because how else do you divide us up, right? And oh, by the way, I'm not so naive, right? The people I would put in the bad guy category think of themselves as the good guys and me the bad guy. So you can split us up or group us however you want, but that is everybody. Since I don't believe that we've been visited from anybody outside the planet, that is everything right there, and it is small. And we're traveling in space together on this spaceship. You were talking about at the beginning, your wife or a friend or colleague saying you might not live.
Oh, my wife supported it. It was the friends and colleagues who were like, you might die. And I'm like, yeah, but it's worth it. My wife even agreed. No, she doesn't have life insurance on me for it. Jeremy, come on, give me a break.
If you're going to find space, call me. I'll give you some help shopping for life insurance. It's a bigger chore than you might guess. But You're gonna die in space. So far, everybody has, right, and you're on this little spaceship Earth, and you're going around the sun. Every year you make a lap. You blow out candles. We all sing. That's our little space flight culture. I'm not sure. I don't know. I didn't start this idea that you blow out candles and we all sing every time you make a lap in our spaceship, but you're going to die on our spaceship. So we should go do something grand with the time we have.
Yeah.
Yeah, we should.
Yeah, for sure.
Yeah.
One last question for you, Tony. Where?
All right, Columbo.
What would you change? What would you change about NASA today if you had the ability to change it?
Yeah. So I gotta believe I've seen the American people and have been part of the overreaction to killing people in space accidents, right? And it is incredibly tragic. However, not doing a mission is more tragic. I was reading it wasn't a blog, but it was a post and with folks' comments and stuff, and it was a bunch of safety folks, and some of them spent a career doing safety at NASA. And one of them started the phrase with "mission success begins with safety." So if I got to change only one thing, I would say, no, it doesn't. It's right there. Go back and read it. Mission success starts with mission. And I think if you stood up and told the American people, look, spaceflight's dangerous, but guess what? You know, texting and driving's dangerous, and we're just going to do the best we can, but we're going to go accomplish a mission, and we're going to do our best to accomplish a mission. And those of us that make it to the other side will mourn the loss of the folks that it took their sacrifices to get us here, but we're going to go get something done, and I would go in a hurry.
It blows my mind that we are so risk adverse to sending 9 people up, but yet we'll fight a war to lower our gas prices. It doesn't make any damn sense to me.
Yep.
So
be bold. You only got this window of time. You should be bold with the amount of time you're given, however long that is.
Agreed. Tony, it has been an absolute pleasure, sir, to have you here. Please come back anytime, and I will. I'm going to harass you with invitations to come hang out with UAPX when we go out on our meetings. Not our meetings, but our expeditions.
Oh, yay, meetings!
Yeah, meetings. Our expeditions. I think that you would be very impressed with the way that we approach the science behind this, because we have all sorts of personalities on the team. Some believers, some non-believers, some people smack dab in the middle, and some crazy guys with strange trucks that go out there and collect data. So I'd love to have you out there.
All right, definitely. Yeah, send me the info.
I absolutely will. Tony, it has been an absolute pleasure. Matthew, do you want to hang out for a little bit more? I know Tony has to bounce.
Sure. Yeah.
Okay.
Have a good evening.
Thank you, sir. Thank you. Enjoy. Bye.
Bye, Tony. Tony's a great guy. I really like
that. That was fantastic. I love his take on things. It's really kind of interestingly refreshing on how he looks at that. There was a question that was posed by one of the guys in the audience. I didn't put it up on the screen because we just weren't going there, but you're a radiation expert, and you understand a lot more about the physics of radiation and human consumption of radiation and things like that. And this was the question that we got, is how did we get past the Kuiper belt? There is, and to expand on this, there is a very large conspiracy that says we never made it to the moon because it is impossible for humanity to get through this really dense area of radiation that separates us from the moon. So as a physicist, with your expertise in radiation. How do we pass through that?
I think you're talking about the Van Allen belts.
I
Kuiper belt is
bel-
rocks. Yeah, it has
Yeah.
nothing to do with radiation. So you must mean the Van Allen belts. But oh god, I know you have conspiracy theory at the beginning of the video, but nothing makes me want to punch someone more in the face than saying we didn't go to the moon. Tens of thousands,
Yes.
hundreds of thousands of scientists, engineers poured in so many hours to get us to the moon. That conspiracy theory is so dumb and so easy to disprove. If we didn't go to the moon, the Soviet Union would have exposed us and laughed their asses off at us.
Yes.
We absolutely went. You can see the damn flag. Okay.
Yes.
I mean, not with a telescope, obviously we don't have the correct resolution, but you can see like the bleached, you can see the freaking landings. Oh, those are faked images, of course. But
So
I think
assuming
we
the
should
Kuiper belt is the Van Allen belt.
Yeah, no, that's assuming the Van Allen belt. Yeah, it's of course you can get through it. It's just a big dose of radiation. I believe it's the equivalent to smoking for a year or something like that, going through the belt for a few seconds or minutes. So it's nowhere near fatal. And people who claim that don't understand how radiation works. So actually, I had radiation safety training at Lawrence Livermore National Laboratory, and I learned the full deal. So basically, you can tolerate something like I make sure I have to say this number correctly. You can go up to 10 times the federally mandated maximum dose and survive without necessarily even permanent ill effects. But nobody knows this, and no one says this because we're so terrified. Like we're saying, I was saying earlier, of risk aversion of the word radiation. Like, remember, Jeremy, we've been talking about this by text messages. People don't realize how much radiation they get on an international flight. The same person will get on an international flight and get all kinds of cosmic rays, will panic over a CAT scan or over the thingy at the airport because they don't understand numbers, don't understand math, and don't understand physics. So absolutely the Van Allen belts are of radiation are dangerous, but they're not fatal. So there's a big difference between large exposure of radiation and large enough to create permanent damage. There's orders of magnitude, and that's the thing most people don't understand is orders of magnitude, the powers of 10, and you're still many powers of 10 away in the Van Allen belts from any sort of permanent fatal exposure to
I'm going to take a
radiation.
wild guess and think that maybe we took this into consideration. I mean, we probably put a little shielding in our crafts that maybe mitigated some of this as we went through it.
But shielding's expensive though. So we can't mitigate it fully because to fully shield the people would require more shielding we're willing to put on because then it would make the craft too expensive.
Sure.
But yeah, no, the Van Allen radiation belts are not even close to a showstopper. It's so funny. Everyone talks about the moon landing as if there was one. We went back multiple times. Okay, there's like 12 people I think who have walked on the moon, and their exposure through the Van Allen belts is probably nothing compared to what I've been doing in the course of my work, especially the past few years.
You sent me a picture of a piece of irradiated salami the other day.
Yes, I did. So
a radioactive piece of salami. So when Matthew is talking about radiation, he knows his stuff.
So I intentionally made some salami radioactive. Oh, great. I hope there's like safety people at my university aren't watching this, but I did this because I was doing neutron activation. That's how you can make anything radioactive with neutrons, but only for a few hours, for a few days. Passes very quickly. I actually ate the salami after it returned to stability. I bet you there are people I couldn't pay enough money to have done that because people often, we were talking about this earlier, they use fear rather than rationality. I'm a rational person. I ate it after the radiation had decayed away to normal levels. I bet you, if you pick any random person on the street, I couldn't have given them $1 million to eat that salami. Probably they'd be like, "Oh my God, it's still radioactive." No, it's not. It's called half-life. It decayed away.
Well, the military. When I was over in the Middle East, we used to have to drink if you wanted a glass of milk with your crappy eggs and powdered potatoes, they gave you what was called. It was brand name by the Parmalat was the brand name, and it was milk that came in little juice boxes, and it was irradiated. It
that's
wasn't
different.
Right.
It's no longer radioactive. So people who panic over that, again, have no understanding what radiation is.
But you should see the people standing in line looking at this thing saying, irradiated milk. And they're like, oh, hell no. It's that fear factor that you're
Oh
talking
God,
about.
it's so irrational because it's even worse than what I just said. It wasn't activated, so it was never radioactive.
Yeah.
So when they say irradiated, what they mean is they use gamma rays to kill like microbes. So the
Mhm.
gamma rays just pass through the milk. They don't make the milk permanently radioactive. So again, it's just fear. It's our
Yeah.
irrational. You know, if we allowed things to be irradiated, I bet you we could probably get rid of pesticides, stuff like that. But people are too afraid. Like, oh, it's still radioactive. It was never radioactive. We passed radiation through it. Radiation's not contagious. The only exception is neutrons, as they said. Other forms of radiation are not contagious. They go through and they're done. So, no, those are great examples from your military experience.
Yeah.
Now,
it's
to be
crazy.
fair, the military did. I mean, this came out. The CIA military did do experiments where they did like feed mentally disabled people and stuff like radioactive cereal to see what happened. Now, that stuff really did happen. There was declassified documents, and that's horrible. But yeah, what I'm talking about is completely safe.
Yeah. I think somebody calculated it at least I read it the other day, that like 1 gram of uranium has like 20 billion calories in it. So if you eat it, you're going to, it's not good for your diet anyway.
No, I wouldn't eat it.
So anyway, there's the answer to the Van Allen, Cooper Belt, which was probably being referred to by the Van Allen
Kuiper
belt.
belt. But just in case the Kuiper belt was being referred to, just in case, space is really big. Yeah. So just in case that's what was being referred to, and it was like, how do we get past the rocks? It's not like The Empire Strikes Back, where it's like, oh my God, dodging the asteroids. When you have an asteroid belt, Kuiper belt, okay, there's a rock here, and then the next rock is over. Like, space is really big. Asteroid belts are not like in the movies, not like in The Empire Strikes Back. So just in case your questioner actually meant the Kuiper belt, I just realized maybe they thought, how do you dodge through all the rocks? Yeah. Space is big. The rocks are really far apart.
Is it actually a belt? Or is it more of a
sphere?
Sphere?
I think it's an actual belt. I think the Oort.
So why don't we just go around it?
Yeah, there you go. Space is three-dimensional. I do think it's a belt, but I don't want to speak nonsense because remember, I'm a physicist, not an astronomer, so I could be wrong. But I do think it's a belt because I do think, like, you know how most of the planets are coplanar? And that's because as the sun form, and it has to do with conservation of angular momentum. Basically, we see this in other star systems too, as most planets will be coplanar with the rotation of their host star. And so I'm pretty sure actually Kuiper belt is a belt. You're right.
Yeah, just
but
go
the
around
Oort cloud, I think, is spherical. The Oort cloud, which has the comets,
or maybe not spherical, but at least
or ellipsoidal, Gary just said hi in the chat. Yeah.
Yes, he did. What's up, Gary?
Yeah.
So, Matthew, anything that stuck? The one thing that stuck out with me with Commander Antonelli is this is a guy who has spent time piloting 2 space shuttles. He's spent time in the space station. He's looked out the window. He's looked at Earth, and he's gone through all the training. He's spent more time in space than most other human beings in human history. And yet he does not believe that we have been visited or are being visited currently by any other type of exoplanet life. That strikes me as not unbelievable, but interesting, especially when we have, multiple other astronauts that are saying the exact opposite. But that goes back to his point that, you take 12 government officials and put them in a room and you got 13 different opinions.
No, I think it makes sense because I think if we are being visited, it's that actual encounters are so rare. I mean, I don't want to believe 100% of every single claim and experience and this and that. I think it's that if we are being visited, it's so exceedingly rare that even with astronauts, it makes sense that some would have seen evidence, others didn't. I think that makes even statistical sense in a way to me, because it's probably really rare. I hesitate to put a number on it, but I seriously doubt that even a 10th or 100% of claimed sightings are actually interesting and worthy, of study. So I think he did say there's lots of weird things that he couldn't explain, things that looked like a rocket, but wasn't.
Well, I tell you, the conversation that I'm also looking forward to is going to be occurring this Thursday.
Yes,
and
I'll be there.
I think you're going to be there with us. And for the folks not in the know, we will be discussing all of this and more with the one of the directors of the Vatican's observatory. So we're actually getting a representative of the Vatican. He's also a professor, I believe, at Arizona State, and he is one of the directors at the Vatican Observatory. So we're going to be discussing all things space, all things science and religion, and trying to get a good feel of where we're heading with that. So I know, Matthew, you're looking forward to talking to Father Corbley in that aspect as well, I think.
Yep.
That's going
Absolutely.
to be a trip. So for those folks listening right now, what I would like to do is I would like for you guys to reach out to me at that email address, scrolling down at the bottom of the screen, next Thursday. I believe it's at the same time. I'll actually have to look. We will be interviewing Father Corbley, who is the vice director of the Vatican Observatory. And I would like for everybody to start sending me some questions that you would like me to pose to Father Corbley, but with the caveat in understanding that we're not going to be discussing UFOs or UAPs. We're going to be discussing I know. The Vatican has reached out, and they've requested that those discussions, mostly because of the sensationalism in recent news articles and things, and the more and more that is becoming common knowledge, the Vatican is kind of backing off from those discussions. So unless it's coming from the top, so to speak, they don't want to breach the idea of UFOs and UAPs. But we can discuss why the Vatican even has an observatory. You know, why is an organization that looked as if it was once shunning science now studying the origins of the universe?
No, that was centuries ago. So, well, this is why Thursday is going to be so exciting, Jeremy, because I'm going to, together with Father Corbley, was his name, right? I'm not familiar with him yet, but I will be. You should compare what my religion, Catholicism, does with other religions are much worse, especially like modern fundamentalist Christianity in America. Like, trust me, if you want to see shunning of science, Pope John Paul II said evolution was okay, and the Big Bang Theory was blessed by Pope Pius XII in 1950 something. So if you want to talk anti-science, we can Galileo was an unfortunate incident, but things have improved. Let's just say over the last
they certainly have, and I think the Pope actually came out. The current Pope, I think he actually came out not too long ago and said that if aliens visited Earth, that he would actually baptize them. So
yes, he did. Yes, he did. Pope Francis did say that. Oh yeah, he caught a lot of flack for that. Yeah.
Yeah, and for the record, I am I think it's safe to say that I am a recovering Catholic and a currently practicing agnostic. So
recovering, I'm gonna have to fix that. Yeah, I'm gonna fix you. I have to bring you back to the fold.
No. I think I've seen enough of the pomp and circumstance to kind of wrap my head around the idea that organized religion under the guidance of man is going to be bastardized from the original ideology in any way, shape, or form that it can be, just because of human nature. So I don't think.
Well, we can argue that another time.
Fair enough.
It's 9:42 my time. I think it's 6:42. I'm falling asleep. My wife's already gone to sleep, texting me the saying she went to sleep. So I'm exhausted. It's so late here. Yeah.
Well, we've got a guy from Portugal that's still awake. So
wow. Well, no, it's not morning. Then it would be, no, it's middle of the night. I guess it's 5 hours from me. Wow.
Yeah. Anyway, folks, thank you for joining in. Make sure to tune in, follow, like, subscribe, ring that little bell down there. Make sure you come back this Thursday for our interview with Father Corbley, the vice director for the Vatican's Observatory. We will be digging deep into science and religion. Matthew will be joining us. And again, thank you to Commander Tony Antonelli, a NASA astronaut, for joining us tonight. Folks, it has been an honor and a pleasure to speak to every one of you. Matthew, thank you again. And we're out of here. Enjoy.
12, 10,
DLS is go for main engine start.
6, 5, 4, 3, 2, 1. and booster ignition and liftoff of Space Shuttle Discovery, taking the space station to full power for full science.
This is Mission Control Houston.
Discovery roll program.
Roger, roll, Discovery.
Discovery's roll maneuver is complete. It is now in a heads-down position on track for its flight to the International Space Station. Discovery flying 365 miles per hour, 1.5 miles in altitude, 7 miles downrange from the Kennedy Space Center. Discovery's engines are throttling down as the orbiter passes through the area of maximum pressure on the vehicle.
Discovery, go at throttle up.
Discovery, go at throttle up.
3 main engines on board are throttling back up. Now 1 minute, 12 seconds into the flight, Discovery flying at 1,800 miles per hour, 10 miles in altitude, and 11.5 miles downrange from the Kennedy Space Center. At liftoff, the fully fueled shuttle boosters and external tank weighed 4.5 million pounds. The total thrust at launch was 6,425,000 pounds. All systems continue to function well. 3 good main engines, 3 good power generating fuel cells, and 3 good auxiliary power units for the hydraulic system. We will now stand by for burnout and separation of the solid rocket boosters. Combined, the twin boosters provide 5.3 million pounds of thrust to propel the orbiter toward space. Discovery now flying 3,600 miles per hour, 32 miles in altitude, 43 miles downrange from the Kennedy Space Center.